Hey, this is Math 7, Unit 7, Lesson 14, looking at surface area of right prisms. So something new today, talking about surface areas. Okay. Alright, so multifaceted. Your teacher will show you a prism, okay? And so what are the things you could measure about the object and what units would you use to make those measurements? So the object of that your teacher showed you today looks something along the lines of this. This is just one from the book here that I just have from my teacher's book. And you can see it looks like a cross type of shape there, or an addition sign, and it has that same face, but then it extends all the way out to make it like a nice 3D image. So we definitely have a face here, and we have these right angles like so, and then we have a height or a length that continues on there. So we could find a volume of this if we wanted to, if we could determine the side lengths here to help us find out the area of that cross, and then we can multiply that by the height. So if we knew these side lengths here, we could figure out that space, and if we knew that length or that height there, we could figure out the total volume. So there's lots of things we could figure out by using that shape, and some things we'd have to know in order to do more work with it there. So we definitely could measure the side lengths, we could measure volume, we could find area, lots of things there. In terms of units you'd use for those measurements there, based upon the size of the shape your teacher showed you, you might choose to use inches, you might choose to use centimeters. It's not an enormous shape, so it's up to you what you might want to use there, but probably go along lines of inches. Alright, so then from there in class, after you've discussed that a little bit, you then have a little picture there in your book of the shape your teacher showed you. Okay, and this one they flipped it over so you can see it's standing on its, on its base, so to speak. And so we have that base right there, and then we have a height right here of 11. So 3 students were trying to calculate the surface area of this prism. Now surface area is the amount of surface that's there. Think about like wrapping a present of some sort. If you had a present to wrap up, it's how much paper would it take to cover that whole present, that whole box up. So surface area is how much space is there would you have to cover up the whole object with a piece of paper, or lots of pieces of paper. So Noah says this is going to be a lot of work. We have to find the areas of 14 different faces and then add them up. So he's saying we add up not just that face, but we add up this face, and that face, and this face, and that face, and this face, and the one you can't see behind there, and all the ones you can't see behind there. We can already see we're at 3, 4, 5, 6 faces there, right, is what we can see, and then you have a 7, 8, 9, 10, 11, 12, and then we have 13 and 14. That's a lot of adding to do, but it can be done. Elena says it's not so bad. All 12 rectangles are identical copies. Well, so she's talking about all these being identical, which looks like they are. They're all 2 inches by 2 inches, so they're all going to be very similar. It's going to be a 2 by 11, so they're all 22 in terms of the area around the whole thing. So, right, so multiply that by 12 is not the end of the world. It's pretty easy to do, right? And then we add on the 2 bases there, okay? Andre says, wait, I see another way. Imagine, and that's what we have to work on today, imagine unfolding the prism into a net. We can use one large rectangle instead of 12 smaller ones. So imagine if you were to maybe cut this right down here. Just cut, and it was hollow on the inside. If you cut that there, you can actually then unfold it and you'd have a large rectangle. That's how that would work out there. Do you agree with any of them? In our case here, you probably would say that we agree with all of them. They all would work in their own way. All some a little more effective than others. So yeah, Noah's right. We could add them all up individually. That would work. Elena's right too. We could do it shorter by saying, well, it's just the area of this times 12 and add those ones. Absolutely. And what Andre is saying is absolutely right as well. We know that we could find the area of those. That's the same as Elena, the 2 bases. That stays the same. But it's like, let's untwist this whole thing, unroll it, and see what large rectangle we have there. So we can do it. It just takes some more thinking to do Andre's than the other one to figure out how do we get to those numbers there. So number 2 asks us, well, how big is the one large rectangle that Andre is talking about? So how do we do that there? Well, let's take a look at the base first of all. You have this cross shape like so. Okay, and each of these has a length of 2. 2, 2, 2, 2, 2, 2. Lots of 2's, right? Hope I got them all. Which means that essentially there's a perimeter around this shape, and it has a length of 2. So if we count them up by 2's, we'd have this: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So it has a perimeter around it of 24 inches, right? But we also know that that's what you'd have if you unfolded it. It would have that this thing spread apart would be 24 inches long, right? If you undid this thing and did each one as a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? You'd have 24 inches like that. But then you also still have this height, which drops down to the 11. So we have 24 by 11 is what that rectangle would look like if you're able to unroll or unfold the whole thing. So 24 by 11 is what the paper size would be. So 24 by 11. It's not asking you for the area, it just wants to know what size paper would it be. And it'd be 24 by 11. Okay, kind of cool. The third question says, will Noah's method always work for finding the surface area of any prism? How about Elena's? How about Andre's method? And be prepared to support your reasoning. So for Noah's way, finding each little shape, that would be a yes, it always works. You could do one shape at a time and add them up. Sure, no problem. For Elena's way, that's going to be a sometimes, but you have to have all equal parts for it to work. It worked for hers because every one of those spaces was exactly the same. So we could do it 12 times 2 or 22, whatever it was going to be, right? We did 22 times 12 because they were all the same area again and again and again, no problem. And then for Andre, does his way work? Yeah, you always get a rectangle and you can fold it around the base, okay? So his is going to work as well with those right angle things because you can end up with a rectangle, and that is going to be your kind of your height section, is that rectangle shape, and then you have your other bases you just add on to it. Which way you prefer? Well, that's up to you. You get to decide which way you prefer, and it's really about what do you see first, what makes the most sense, and how does that work out for you. Let's look at part 3. Alright. Between you and your partner, choose who will use each of these two methods to find the surface area of the prism, either adding all the faces together or using the perimeter of the base. This is kind of the new method here, so I'm going to go ahead and do it that way. So you could do it the other way if you wanted to by adding all the areas of the faces. Up to you. There's a lot of faces in this shape here, so I'm going to use the perimeter method just so we can practice doing that together. The perimeter method says, let's take a look at the base we're talking about. And that's the base we're talking about here. We can see we have a 7, a 2, a diagonal length of a 5, a 3, and a height there of a 5. So the perimeter of this shape is 5 plus 5 is 10, plus another 5 is 15, plus 7 is 22. So our perimeter is 22 for that shape right there. Okay, so that's going to be one length of our shape is 22. So we'll put that there. And then the height of our shape is going to be our height here. Again, that's our base. We take the perimeter of the base times the height, and that's going to be 8. So we have 22 times 8, and 22 times 8 is going to be equal to 176. So this rectangle that goes around that is 176. Now I need to find what the area of just this shape is by itself. So to do that, I'm going to cut this in parts like that. So if this is 2, then that makes this length right here 3. And if I chop this right here at 3, that's 3. 3 plus what gets you to 7? 3 plus 4. So this has a height of 3 if I bring that across. So a 3 and a 4. This 5 I don't actually need. So So I can kind of ignore that there. Okay. And let's see what we have. So now I have this rectangle is 2 by 7, which is going to be equal to 14. This square is 3 by 3, which is 9. And this space right here is going to be 1/2 of the base, which is 4, times the height, which is 3. Half of 4 is 2. 2 times 3 is 6. So the area of that face is all together 15 plus 14, which is going to be 29. But I also have it on the back side for another 29. So 29 and 29 equals 58. So that's the area of the faces, bases. So what happens is I have a base plus another base plus the rectangle using the perimeter method that goes around of 176. Okay, so we have 176. Oops, I did this times 2 already, so I don't have to do it twice. I already added them up there twice. Okay, so those are my two bases plus the area of the rectangle. So 58 plus 176 becomes 234 centimeters squared. And again, it's surface area, so it's squared. So lots of steps in this, so don't think it's going to be done quickly. It takes some time and perseverance to kind of work yourself through that there. Alright, let's take a look at today's summary. So the idea with the summary today of today's lesson, it really comes down to right here. So there's another way to figure out surface area for prisms. This is we can treat the prism as having 3 parts. 2 identical bases and 1 long rectangle that's been taped along the edges of the bases. So that's the idea there. We can look at a prism as saying it has 3 parts, 2 bases, and then 1 giant rectangle that's been cut up and it needs to be put back together. Okay, so take some time to do your homework and then come back and check it with us. Alright, here we go. Number 1, edge lengths are given in units. Find the surface area of each prism in square units. Okay, so here we go. What we're going to do is we're going to find the area of, we have a base here. And in this case, what I can do is I can know that I have a base. Surface area is going to be, if I remember right, it's a base plus a base plus the rectangular thing I can figure out, right? So in this case, I have 10 times 5 is 50. So I have a 50 plus another 50. And now I need to find out what is this perimeter. All right, so I'm already at 100. The perimeter is going to be 5 and 5 and 10. So that's going to be 20, 30. So the perimeter is going to be 30 times the length, which is 8, so that's 240. So I had 100 to start with, and I have 240 that goes around the rectangle, so I'm at 340 is my surface area for A. Alright, next one. Let's find the area of our base, which is the rectangle, triangle. So 1/2 of 6 times 8. Right, so half of 6 is 3. And 3 times 8 is 24. 24. Now I have 2 of those, so 24 plus 24 equals 48. Now let's find the distance around. This tells me that I have a length of 10, so the perimeter is 8 plus 6 is 14 plus 10 is 24. So I do 24 times the length, which is 15, and 24 times 15 is a nice big number, which I did not jot down earlier. So I'm going to calculate 24 times 15 is 360. So we do 360 plus 48. We combine those together. And 360 and 48 is going to be 408. All right, this next one. I have a base right there. We can call that our base there. And it's a 4 by 5. So that surface area of that base is 20 plus another 20 on this side over here. So that's going to be a total of 40. Now this perimeter is going to be 5 plus 5 is 10, plus that 8 is 18. The perimeter is going to be 18 by 13, the distance there, 18 by 13, and 18 times 13 is 234. 234. So I add that with what I started with on my ends, my bases. It gives me 274. All right, the next one. My base is going to be the triangle shape right there. And so it has I have to use one with a right angle here. I have to use that as my height, so be careful about that. So be careful to use that as your height for your triangle. So 1/2 the base, which is 5, times the height, which is 12. And you might not remember that rule, but I have to use the height that goes with the right angle there. Okay, so 1/2 of 12 is 6. 6 times 5 is 30. So I have a 30 and a 30, which means I'm already at 60. Now I use the perimeter method. So that's going to be a 5 plus 12 plus 13 is the perimeter, and that equals 30. And I multiply that by the height, which is 8, to get 240. And I add that to the 60 that I started with to end up with 300. Alright, and our last one here, we have a triangle. Notice it says that it's 4. That means our height right here is 4. So the area of that base is 1/2 of the base times the height. So 1/2 of 6 is 3. 3 times 4 is 12. And I do that twice because of why? I have 2 of those, 12 and 12. So 24. Then we find the perimeter. The perimeter here, that has this hash marks there, which tells me it's a 6 plus 6 plus 6 is the perimeter. Okay, I have that times the length, which is 12. So I have 18 times 12. And 18 times 12, last time we checked. Oh, why did I say, sorry, it's not 6, it's 5 and 5, my mistake. Looking at my notes real quick, back up real quick. These marks mean that it's the same as this, which is the same as that. So it's actually 5, 5, and 6. So plus 5, plus 5. So it's actually 16 times 12. Sorry about that. Which is 192. We're going to combine those together to then have 216 is the surface area for E. There you go. Lots of work on that one. Number 2. Priya says, no matter which way you slice this rectangular prism, the cross-section will be a rectangle. May says, I'm not sure. Describe a slice that May might be thinking of. Let's take a look at the picture here. So, Priya says, you always get a rectangle no matter how you slice it. That would be true if you slice it horizontally, right? If you slice horizontally, sure, you can get a rectangle. That's not a very good one there, right? If you slice it vertically, you can also probably get a rectangle, right? But if you slice it right across here, for example, you would not get a rectangle. So it's not going to work for that one there. So it doesn't always work. You've got to be careful. It only works if she was to slice it vertically or horizontally. If you slice it at an angle, you don't end up with a rectangular shape. All right, number 3. Oh, hopefully that was on the paper. Sorry. Can't cut off a corner. Okay, cool. Number 3. B is the intersection of AC and ED. Okay. Find the measures. Here we go. It says ABF. So ABF is ABF, this thing. So this is going to be 110 plus 120. 110 plus 20, sorry, for 130 degrees. Is that whole chunk there. ABD. Well, ABD is this space right there. And so to find that, we have to do a couple things. We have to kind of look and say, well, if this is 110 here to here, this is going to be a straight angle from here to here. So this bit right there should be equal to 180 degrees. I've already used 110, so 180 minus 110 tells me that what's left here is 70 degrees. the measure of EBC. So EBC right there, that chunk. Knowing that that's 70, what do I have? I have across from it, I don't really have a vertical angle, do I? Okay, my vertical angle would be the whole thing actually. So actually I do this whole part right here matches this part here. So that matches that. So I do have 70 for EBC is also 70 degrees. But what I want to know next is what about this little space right there? Well, if the whole thing is 70 and I know that's 20, I'll do 70 minus 20 to make what's left is 50 degrees. So this is 50. And finally I have DBG, which is this space right there. And again, so knowing that I can do it a couple different ways here. Knowing that I have, I could look and say, knowing that's 70 and that's 65, I can look at the whole thing here and make that a supplementary type of angle. And I could do 70 plus 65, which is 135. And then we could take 180 and subtract from it 135. And we end up with 45 degrees. There are a couple other ways you could do that, but that's just one way of doing it. All right. And then finally, looking down here at this one, I think it's a finally, there's a couple more. All right, write with fewer terms. I can combine 12m minus 4m, and I can make that simply an 8m. Here I can put a 12m and a 1m together to get 13m minus 5k. That stays just like it is there. And there's one more of these like that on the next page. What's good to do here is to rewrite this, right? So we can get rid of the parentheses if it helps you out. 9m plus k, and this becomes minus 3m. And then when I do a minus with a minus there, that becomes a plus 2k. So I'm going to group those together. 9 minus 3 is 6m, and a k plus a 2k is a 3k. All right, and number, oh my goodness, off the page again. It's really hard when your projector shoots on a wall that's behind you pretty much. Sorry. So 44% of 625, find it using the facts that 40% is 250 and 4% is 25. Well, 44% last I checked is 40 plus 4, right? So if this is 250 and this is 25, that gives me 275 is what 44% is going to be, right? No problem there. So now if I want to do 4.4%, I'm going to move the decimal over 1, so I'm going to put 27.5. And if I want 0.44%, I'll move it over 2 places, and we have 2.75. And that's it for today's homework. Hope that helps you out. Have a great one. I'll see you next time.